Hello and welcome to Season 2, Episode 12 of LogiCast, the AWS News podcast brought to you by Logicata. John and I are back from our travels in Barcelona last week. We're back in our sheds. And if you're watching the video feed, you'll notice we are both wearing the very same fetching swag from our trip last week. So how are you doing today, John? And how did you enjoy Barcelona last week?
Oh, I've just about recovered, I think. It was good. It was definitely good to be in a room with everybody. Some good conversations were had, but it was kind of 3 long days, and I've just about caught up, I think.
Yeah, it was definitely very tiring compared to a remote working day, but I think once a year we can put ourselves through the pain for the benefit that we get out of it. So yeah, I certainly had a great time collaborating and meeting some of my remote working colleagues for the first time. So yeah, looking forward to log off 2024 in an as yet unnamed destination. So anyway, we're not here to talk about our travels. We're here to talk about AWS news. So if you're new to the podcast, every week I collate a list of AWS news, which I circulate via my weekly AWS Roundup newsletter. John and I then handpick a subset of those articles that we want to talk to you about in the podcast. So this week, we've got another set of articles, and the first of those is an article from the AWS DevOps blog. And this one is about unit testing AWS Lambda with Python and mock AWS services. So, John, what can you tell us about this article on unit testing for Lambda?
Well, unit testing serverless applications, because that's fundamentally what this is hard. Okay, it is. It's hard because you've got so many different things. There's lots of black boxes in there. You just kind of interface with them. How do you test that? How do you validate that? How do you mock those out and all that kind of stuff, right? This article does a fairly common setup of API gateway, Lambda, and then a Lambda's talking to DynamoDB and it's talking to S3. Right, that's pretty common. That's a fairly normal setup. The Lambda itself does some basics. It grabs something from DynamoDB, stores it in S3, returns to the user. Right, and what it's doing here is it's showing how you can mock out things like DynamoDB and access to S3 so that you can test locally without having access to those services. So it's using Python and it's using Motto, which makes sense if you know that Python AWS SDK is called Botto, so it's Motto because it's mock Botto. Clever naming, really. And it's mocking out Dynamo and it's mocking out S3. It's setting up, it's tearing down, it's running the tests, it's verifying that it writes to mock S3, and it's showing you how to do that. And it's testing things like data not found, and it's checking that the handler's doing what it's supposed to, and all those kinds of things. It's really handy. It's really helpful. It all works through PyTest. So if you're familiar with PyTest, this probably won't be anything too out there. Just throwing Motto in there rather than any other mocking tool that you may be used to using. So it's good. It's useful because, as I say, it's really hard to test these sorts of things that integrate with lots of other things. It just becomes a pain in the backside. Like in the project that I'm working on at the minute, it's in TypeScript rather than in Python, but I've been mocking them out with just normal jest mocks. So it's mocking out a call to a database, it's mocking out a call to parameter store, and it's just kind of replacing that with expected returns. So this is good. This is what they call prescriptive guidance, which is kind of like an opinionated way on how you could do something. Like, here's how we think you should do it, which makes sense coming from AWS because they built the service. You'd like to think they know how to test things that are running in the service. You'd like to think. But what I find most telling about this is an article only from like the 22nd, right? So from this year, and Lambda's been around for I don't know how long, but at least 3-4 years. So why has it taken this long to get to this point?
Good question. So excuse my ignorance. As we know, I am not a developer. So these mock services, is this just code that you can run locally on your machine that simulates the
Yeah,
AWS
kind of. So
services?
what it's doing, what a mock does is it intercepts a request out to a service and then returns the response as if the service had returned said response. So what you're doing is you're kind of tricking your code into thinking that it's talking to Dynamo when in fact it's not talking to anything. It's just, I've made a request, I've got my response. Great. It doesn't really care where it's come from. You're just tricking it into thinking that it's come from Dynamo.
So you can run this anywhere without actually consuming any AWS services, right?
Yeah.
Yeah, while you're developing a project. And another question I had, slightly unrelated, but I just wanted to ask how the PTSD is going these days. That's the Python to TypeScript stress disorder from the project that you're working on at the moment.
Getting there. Now that I'm over the hump of getting the first bits done, then it's getting there. It's getting there. I still prefer to do it in Python, but there we are.
Fair enough. Yeah, as always, the links to these articles will be in the show notes for the podcast. All of the code for this mock testing framework is available in a GitHub project, which is linked to from the article. So if you want to try it for yourself, go right ahead. Moving on then to our second article this week, and this one is about deleting empty CloudWatch log streams. It's from the AWS Cloud Operations and Migrations blog. I guess there's a couple of questions I've got here. Why would you have empty CloudWatch log streams in the first place? And I suppose the second question is pretty obvious, but why would you want to delete them? I guess if they're empty, they're no use to man nor beast. I'm curious as to how these come about in the first place.
So a number of AWS services write to CloudWatch logs just by default. The one that I tend to use as an example of this is Lambda. Okay, Lambda logs to CloudWatch logs. If you don't tell Lambda where to put them, and you actually can't tell Lambda where to put them, it creates a log group and streams in those groups automatically for you and sets infinite retention on them. That's quite bad because it means that it's hanging onto logs and your CI/CD is not in control of things like the log group, the creation, the retention, tearing them down. So you delete said Lambda, those logs are just still there forever. So it can be kind of messy. Why you'd want to delete empty streams, or how you end up with an empty stream, I should say, is kind of the next thing. Okay. So once Lambda has created this infinitely retaining stream, you, in theory, might have another process that says if any stream is created with an infinite retention, go and set that to a known retention, 90 days or whatever. Because that log group, log stream, streams live within groups, because that log group is not being managed by your CI/CD process or by your infrastructure as code through whatever process you're using, you delete that Lambda because you don't need it. It gets subsumed into something else. It gets broken down, whatever. That log group will eventually just empty and sit there doing nothing, being empty. It doesn't cost you any money, but it's untidy, and we like tidy. So it eventually sits there, it empties, and then you've got this empty log group doing nothing, right? You could, in theory, write to that log group if you wanted to, but it's not being managed by anything. You're not controlling it. It's just kind of there. And then this comes along and cleans that out. So that's kind of how it happens and why you'd want to do it. Conversely, there is a risk here because, again, in Lambda land, if you've got, say, a Lambda that's not called very often, it's in development, whatever, and you've got, say, a 1 week retention on your logs in there, because it's only dev, you don't need to keep it, you don't need to spend the money, but it's managed by something like CloudFormation. If you go and delete that, CloudFormation breaks because it can't cope with the fact that it thought there was something there and it isn't there. Terraform copes because it will just recreate it. CloudFormation goes, this isn't how I thought it should be, and it just falls over. So it's kind of double-edged. It's good because it's tidy. It's bad because it can break deployments in certain tools.
We do like tidy. I guess if these log streams are empty, though, there's not going to be any kind of cost implication to having them there. It's just, orphaned. Well, it's not infrastructure really, is it? But it's just, I guess,
mess.
Mess that needs to be cleaned up. I need to get our CTO onto that because he often describes himself as the cleaner, and he loves to go around sweeping up the mess. So cool. Anything else to say on that one, John?
No, not really. Like I say, it's just one of those make sure that you're not cleaning things out that might have things writing to them still, because it can balk things.
And again, there's some code snippets here which could potentially be useful. So if you want to have a look at those, check out the article in the show notes. Moving on to the next article. Oh, this is a long title. Let's see if I can get through this without tripping myself up. So this one is about Amazon Aurora Postgres adding write-through cache to improve logical replication performance. So we like Aurora, the internet scale database from AWS. And here we've got a new feature, which is the write-through cache. So tell us, John, how this is going to improve your Postgres performance on Aurora.
You did get that title wrong. It's PostgreSQL.
I don't normally. Most people don't normally pronounce the QL that I've heard. So I guess that's probably a potato, tomato.
I mean, you could call it PostgreSQL if you wanted to.
I've generally heard it referred to simply as Postgres because adding the QL on the end is a little bit cumbersome. But yeah, I guess that comes down to personal preference.
In terms of what we're talking about in this article, rather than me picking on your pronunciation, because I know you like to do that to everybody else.
Pronunciation.
Yay. Schedule. In terms of what we're talking about here, so you can have things like read replicas. Aurora will manage these for you. Great. But if you're doing quite a lot on one of your instances, on your writer instance, then there might end up being lag in your reader instances because it's just not able to keep up with the sheer volume of things you're writing to the writer instance. And that's bad for obvious reasons, but the big one being your data is then stale in your replica, and that's not great. You don't want that, right? The whole point of a reader endpoint is that it's up to date, very nearly up to date with your writer endpoint, so you can write from one, read from the other, and kind of split the load. Yeah. What this is doing is this is allowing you to write to a cache. This is what's called a write-through cache. You write to the cache, that writes back to the database, and what that's doing is that's improving the replication lag. What do I mean by improving the replication lag? I mean lessening the lag, right? The average replica lag in megabytes on this article has gone from, with zero cache of about a 2 gigabyte lag, to a 16 meg cache with a 1 gigabyte lag, and then a 2 gig cache of an 860 megabyte lag, right? So it's really seriously carving that lag down in something that's really kind of CPU write heavy. We like caches. Caches are good, especially I like write-through caches because if you're a write-heavy application, having a lazy loaded cache is kind of like, what's the point? Context for the listeners and for yourself as a non-engineer, the two types of cache that you have are write-through, which you write to the cache and then to the back end, or lazy load in that you read from the cache, and if it's got it, it returns from the cache, and if it doesn't, it goes and gets it from the back end and then returns it. Okay. You can pre-warm your caches, but write through you kind of don't need to, because you write to the cache, you read from the cache because you've written to the cache, which is great. But yeah, there's no part. That's kind of what caches are doing. And what this is doing is it's allowing you to you write to the cache writes it back to the database then replicates much faster because it's kind of normalizing the inputs, it's making things smoother and so on and so on. It's enabled by default for clusters using logical replication on version 11.17, 12.12, 13.8, and 14.5, which are kind of like the most recent minor versions of those major versions. But of course, if you're using Postgres 11, you need to get off of Postgres 11 Toot Suite because you've only got about 9 months before that goes end of life. But yeah, all the major versions that you can use in AWS already support this if you're using replication. So just crack on.
Is it wrong that I'm now triggered by the word cache?
Cache.
Every time you say cache, that's what I hear in my cache in my mind. It's I need to break that association, that word association that's going on. And what is your favorite type of cache, John? Is it I was suspecting it's probably the lazy load because you're always telling me how lazy you are.
It depends, right? You can't use a lazy loaded cache on something where you need to read after write because you'll have written to it, and it won't necessarily be in the cache, because in a lazy loaded cache, you're not writing to the cache, you're writing to the back end, and then you're reading from the cache, and then the cache has to go and get it from the back end. So if you're writing something and then reading it immediately after, you need to use a write through cache. If you're writing something and then reading other things, or if it's the worm model, write once, read many, then a lazy loaded cache is perfectly acceptable. So it depends on what you're trying to do.
So lazy loaded cache is not just for lazy people like you.
You can pre-warm lazy loaded caches. So the idea is you can kind of preload them if you're kind of managing lots of the caching and things yourself. So you can sort of put like the top 10% of things that you think you're going to need in there. And then anything that you didn't think to cache will just be grabbed. But it's one of those, if you're pre-warming a lazy loaded cache, then you need to think about probably using a write-through cache, because it's like, well, what's going on here? Or you've got your eviction settings wrong or something like that.
Fair enough. Well, that sounds like a great new feature to help people improve their PostgreSQL performance. There's a note at the end about AWS dropping support for Aurora PostgreSQL 11.x versions in January 2024 as well. So, yeah, I guess any listeners who are currently using that version ought to be doing something about it, because that is not very far away.
No.
Cool. Okay, let's move on to our next article for this week. This one is about AWS introducing global condition context keys to improve EC2 security. So obviously anything we can do to improve EC2 security, and indeed security of a customer's AWS environment, is well worth knowing about. So tell us, John, how can the use of global condition context keys help to improve EC2 security?
I mean, you could read the article. I don't need to tell you. Oh, wait, no, that's why we're here, isn't it? So I can talk about it.
Yeah. People who want to read the articles, they can just read the newsletter. They don't have to listen to us waffling on. So, yeah, but some people like your dulcet tones and therefore would prefer you to tell us about it, so they don't have to read it because they're lazy like you. Think of them as the lazy load cache type person.
Is your lazy loaded cache in Sao Paulo?
Yeah. I don't know. If it is, it would be the most expensive lazy loading cache on the planet. So
I know you're not listening, Ryan, but if you are, I mean, we love you, but seriously, man.
Well, he got away with it. He got away with it, and his company was worth billions. So I might adopt it myself, actually.
Oh, sell out to Pluralsight, sure, okay. Right, on message. So, context condition keys to improve EC2 security. So, with your EC2 instances, let's get something out of the way. You should not be putting credentials on your boxes, right? You shouldn't be creating a user and then putting an AWS credentials file on the server with an access key and a secret key. You should not be doing that.
But
This
people
doesn't
do.
fix that. I know.
Lots of people do, because it's easy.
It's not, though. It's no easier than doing it properly. It's just a little bit less opaque, I think. But once you know how to do it properly, and context, the way to do it properly is you create a role. And honestly, you shouldn't be attaching policies to a user directly. They should have a role. And then that role has an instance profile. It just does. You don't have to create it. It's just there. And then you attach that instance profile to the server. Done. In the GUI, it even says attach IAM role. It's that easy. So this doesn't fix for that. You still need to do that properly. What this does is this restricts the usage of that role to known IP addresses. Lovely. Lovely. Why is that good? One of the key things you tend to find in pen tests and cyber attacks and all the rest of it is people have got into one server and then they've done what's called pivot. Pivot means pivot, right? They've gone from one thing and now they're looking somewhere else. This prevents pivoting off of those boxes. It means that those credentials are no good if you're not on that machine. So you can't hop and then get the creds and then use them locally or whatever, because the IP will not match. Great. This doesn't mean that you can just grant your servers, administrative access, because then that rather defeats the point. Because if you've got admin access on the server, then you didn't need to get off of the server anyway. You've already got admin access. But if you follow the principle of least privilege, and you've added this context key to say that this IP address, this role must, requests using this role must come from this IP address, then it can only do what it's been assigned to do, which your EC2 instance should only have permission to do the things it needs to do its job. Things like reading from S3, writing to Dynamo, those kinds of things. Things that aren't create a new server unless there is a damn good reason why your server needs to be able to provision new servers. It's rare that needs to happen, but it does occasionally. That kind of thing. And even if it can provision a new server, it shouldn't be able to provision new access keys. It should only be able to use existing access keys, and so on, right? So what this is doing is, as I say, this is kind of locking down one element of pivoting. Up until now, as the article says, you could still do this. You had to set a condition and source IP. You had to kind of do it manually, and that's no good because elastic IPs can change. Yeah, and you have to go and change your permissions, and just it's a whole mess. Doing it with this, with condition keys, it's saying that it's taking all that nastiness away, and it's meaning you're not having to hard code things like source VPC and VPC ID and those kinds of things. It's just saying that, relative, what's the source VPC that I am sitting in? It must come from here. What's the source IP of this server? It must come from here, right? So you then can't take that and go somewhere else.
Cool. I was triggered by another word in that particular description there, and this time it was role. And I know you were talking about IAM roles, which is spelled ROLE, but we don't normally record this close to lunchtime. And every time you said role, I was imagining a lovely kind of tuna salad roll, and my stomach rumbled every time you said roll. So I think we need to go back to recording earlier in the morning. So I'm not triggered by words that sound like food, which clearly has got nothing to do with what we're talking about. But as is often the case, I digress.
So I just love the idea that your requests can only happen if you're currently eating a bacon roll.
No, I wasn't thinking bacon. I was thinking healthier, a bit of tuna salad, that kind of thing.
Tuna's full of mercury.
Bacon roll is more breakfast, whereas a lunchtime roll, something different. Anyway, that sounds like a great new feature to help users improve the security of their EC2 instances. So well worth a read if you want to find out more. So moving on to our final article this week. This one is a slight diversion from our usual subject matter, because typically we're talking about positive stuff and technical stuff. This one a little bit more of a negative announcement. We haven't really mentioned it on the podcast before, but it's been in the newsletter a few times, and it's an article from CRN about layoffs on the way, as Amazon is cutting 9,000 employees. So obviously there's a bit of an adjustment going on globally at the moment in the economic world, and lots of companies are feeling the pinch, and Amazon is no exception. So whilst they're still posting eye-watering growth figures, the organizations do need to keep an eye on their bottom line. And in that vein, Amazon is looking to cut 9,000 employees. Now, that does sound like an eye-wateringly huge number, particularly for someone like me that comes from a small island with 80,000 people. That's more than 10% of the population losing their jobs. But I guess if you put it into a global perspective, I had a look, I think Amazon employs about 1.5 million people at the moment. So I guess it's a relatively small number in that context. Slightly larger number in the context of AWS, but I don't think the article says how many of these 9,000 will be coming from AWS. AWS, I think the estimates are 60 to 65,000 employees globally in AWS. So if they're all going from AWS, that's a huge number. But we don't get to know how many of these 9,000 are regular Amazon employees and how many of them are AWS. But what are your thoughts here, John?
Well, this is the second round of redundancies, right? So they did, 18,000 earlier in the year or late last year, and AWS largely escaped that, which we thought, okay, cool, that makes sense because, it's AWS, they're sort of a little bit insulated from this, and maybe they're not anymore. It's another 9,000 on top of the existing 18,000, and these are mostly in AWS, PXT, which I'm not sure what that is, the advertising arm, and Twitch, because obviously AWS, Amazon run Twitch, they own Twitch, they run it on AWS as you'd expect them to. We don't know where the breakdown's going to be. It might be, kind of a fairly even split between them. It might be more coming out of the advertising. It might be lots of AWS recruiters that are getting the shove. We don't know. We genuinely don't know. What bothers me about this is they will have now shifted 27,000 people out of what, 1 million. It's not a big number in context, but that's 27,000 people that have to go and find another job. Not ideal. And they're still growing. I don't. Maybe this is small brain, and I'm not going, we need to cut so we can grow faster. I'm going, no, you need to keep employing people so they can feed their families and keep roofs over their heads and just not have such a mad profit. And I think this is, I'm turning into a communist, quite frankly, but I think what this is showing is the just mad disconnect between what the markets want, which is this insane appetite for growth, and what reality kind of is saying, which is we could grow a little bit slower, that's okay, but then stock prices go down and more people lose jobs for some reason. I don't get it. I don't. Maybe I am a communist.
It's all about retaining profitability at the end of the day, isn't it? I'm sure they'll carry on hiring. In fact, I'm sure they still are hiring. Certainly articles that I'd read about the previous round of redundancies seem to be pointing to the fact that it would be more people in the recruitment side of things in AWS. So as the recruiting is slowing, it makes sense they're going to need less recruiters. I don't know how many recruiters they employ, but if they've got 1.5 million employees, probably need quite a lot of recruiters. PXT, by the way, is Amazon People Experience and Technology.
What do they do?
They invest heavily in technology and make Amazon the best place on the planet to work.
Oh, it's like an outsourced HR thing.
I guess so. Yeah. So
outsourced,
that kind of
insourced, mid-sourced. Yeah.
Ties in with what I was saying about recruiters. Recruiters and HR. Seems to be the area they're focusing on rather than technical resources, engineering, and solutions architecture, and so on and so forth. So,
yeah, I mean, you're a salesman. I'm an engineer. We're very used to kind of being in safe-ish roles, particularly on the consulting arm, because in downturns we pick up work people trying to minimize their costs, and in upturns we pick up work people trying to move more to the cloud. So it's a very interesting position that we find ourselves in, because we can kind of almost sit on the outside and sort of comment. But yeah, I feel for the people. I do. I'm not feeling for them. I'm not trying to touch them, but I feel for them.
We're back on touching again. There was a lot of talk about touching last week. Thankfully, it remained talk and nothing inappropriate occurred. Before we get back into that, I think we should probably wrap up the episode. So thank you for listening. That was season 2, episode 12 of LogiCast. We will be back next week with another episode for you. We will see you again next time.